Hello everyone, this is Rahul Boya and welcome to my YouTube channel Learn AI with Rahul. And today in our course we're going to discuss about another data type, the first data type in Python, first basic data type in Python that is called integers. So what are basically integers? As I had already introduced in the first video, earlier videos, we were discussing all the data types in briefly. Integers are any numbers which are perfect, perfect numbers. That means that they are not decimals. That means they are not, do not carry any negative. How do I say? They are not basically decimals, and not they do not have any numerators, divided by denominators kind of thing. If you take the example, if you can look into the first cell, this I initialize it with the help of int1 as one of the variable, and if you look 13224, it's a perfect number and it comes into the category of integers. So if I try to check that whether it's integer or not, I can simply do, there is a keyword in Python called type. It's basically a function where we can check whether our variable is of which type. And we can see it simply saying yes. So in our this particular lecture, we're gonna extensively discuss what exactly are integers, the few of the methods, how we're gonna initialize them, how we're gonna use them for our practical purpose. So please try to understand one basic thing. In Python, every data type is a class. So in our class as well, this integer is basically a class. And always remember, I'm going to take all of this thing in the later half of the course, but for every class there are certain methods that are predefined by the developers of Python. So in our case, if you look at this initialization of variables, if I try to see, if I try to print the type integer x, oh sorry, there might be some, okay, I'm not run this cell. For this one, you can see there is a class. So all I'm trying to say is that every data type is basically a class in Python. So you might right now is getting the question that what exactly is a class? What exactly when I'm saying what is the method, what exactly are the methods of that class? So all of these things we're gonna discuss in the later half of the course, where I'm gonna introduce you to the OOPS concept in Python, and we're gonna extensively discuss all of this. But right now, please try to understand class is some sort of a blueprint, some sort of a predefined basic structure that is provided by us from the Python community, from the Python developers, and ultimately we're gonna create the objects out of it. So class is a blueprint, and objects are the basically memory representation, or its actual, concrete form of that abstract class. So eventually, I'm gonna discuss all of these things. This might sound a little complicated at this moment, but Python is basically has given us that liberty, to play around this kind of basic classes. So integer is one of them. Integer is obviously the first of them that is what I'm going to discuss. So when I'm saying integer, everybody knows integer performs certain basic arithmetic operations that includes addition. So if I try to print this all of this thing, some result. Okay, and if I check, yeah. So if I try to print, the value of x is 5, and here the value of y is, value of x is 5 and value of y is 10. So it's expected that the result must be 15, and eventually you're gonna see that. Then there is a difference. This operations, as everybody knows how's the how we usually define these operators in our maths, like plus is for addition, then we have minus for subtraction, and then we have um, product is there is this sort of cross. We have the star that's popularly used in Python. Since we do not have any cross on our keyboard, they are extensively given as a star as one of the symbol. And there is a division. In case of division, is that the quotient value that we often get, the if I try to divide, let's say, by 5 by 4, and here you can see that the quotient is 1, and there will be some value to the remainder. So in our case, we give a slash to form that part, and I'm gonna get the quotient Okay, and ultimately at the end of it, there is a modulo operator. That's what you're gonna use for reminder as well. So if you can see over here now, try to print all of that. Okay, it's not picking that up. Yeah, sorry, I might have a bit of might be a typo. Question V and question B. Okay, yeah. So I have taken 5 and 10 as one of the numbers. You will have all of those results. You can see the sum result is 15. Difference is obviously minus 5 since I guess y is greater than x. So we are basically dividing a smaller number than a larger number. We are getting the negative difference. Then we have product. Then we have quotient. Then we have remainder. Yeah. I try to change the number. Let's assume that I'm going to take x as 20 and here is as 5. You can see over here that now we have the different kind of results. I hope this is not very complicated to understand. Within a few bits of practice, you can actually get good onto it. Then we have the third operation. That is what we're going to do is the exponential operation. Exponential, as everybody knows, ultimately we're going to raise to the power of some value. So if I try to see if I initialize x over here, let's assume that x is basically 3, x is equal to 3, and if I try to see the power result, sorry, print power result, and if I try to print, you can see whatever the value I'm gonna give after this double star symbol is basically gonna give me the to the power of that value. If I try to give it as 3, it's expected at 27 with the answer. You can see. So that's how we're gonna use it. If I try to give it a 4, it will again give me that value. So this everybody knows, ultimately if you have to find a square, it does something like this. It's basically, in other words, it's giving me the value in the form of x multiplied by x is kind of x multiplied by x. If I give me 3 over value over here, so it will again have to add 3 over here. Sorry, x multiplied by x multiplied by x. That's how we can do it. I hope you have made this thing clear. Then ultimately we can decrease the value of x by x. That's how we can do. But this is a very little bit complicated syntax if you can see at the moment. I just want to simplify it for you. You can actually use this, you can actually use this in this way. I'm just going to take this over here. Yeah, you can use this thing in a this way. That's also one of the thing. If I give the plus, and now if I try to print, now if I initialize, let's assume, when I'm saying increment, ultimately I want to try to increase the value of x. I can simply do that. If I try to print, you can see over here that the value of x is now 11. If I try to raise it by, let's say, 5, it's expected that the value is now raised by 5. Its value we got is 15. So increment, this syntax, particularly I was talking to, is also equivalent to this syntax. What I'm trying to tell you is that you can use this way as well. So nothing complicated in this case as well. Okay, if I try to give this one, you can see I got that. If I give 90, I have to get the 100 over here. The same goes here as well. If I try to initialize the value of y as 10, and if I try to reduce it by 1, I would get the value as 9. If I try to initialize the value as 100, and if I try to reduce it by, let's say, 30, it's 70. I hope this is again a very, very common operation that is going to used in a lot of our Python programs. The second one is type conversion. In popular notion, it's also called as type casting. So please try to understand is that we're going to convert the integer value, integer value into string value. If I might try to, let's assume that I got this x as over here 30. Okay, if I try to print original type x, if I print after access to access. Yeah. Okay. So basically, what I'm trying to do over here is to change the data type altogether. So when I try to do that, you can see earlier it was an integer class value, and I simply by giving x, by simply putting str is one of the operation onto it, by simply try to conversion into it, you can see over here that it's taking up that value as well. We can simply typecast this value. So yeah, I mean this is also very simple. You can do it for the same way. You can also do it for other way around. If I have the value which is string, so definitely know it's an integer value. We can do it. We can actually retypecast it into integer as well. So you can see over here. So if I try to print the original, if I try to give y over here, and if I try to typecast it, you can see earlier we used to have. Okay, sorry, there is some sort of typo. I guess. Okay, I have to put it over here as a var string. Okay, sorry, my mistake. Yeah, you can see earlier we used to have the string as one of the value, and then there were the integer right now after typecasted. So we can do this both the conversions. Then the next operation that we're gonna do is that we're gonna actually get the print absolute value. Since if you have certain values, let's assume that might be negative values or for that matter some decimals, we can actually convert it into the absolute values, the integer part of it. So if I try to print this value, you can see I got the 10. So if I try to print the absolute value, okay, I'm going to take the other one. Let's assume that I have 13 point something. Okay. So ultimately, this value, you can see over here is that since this value is a negative value, it has ultimately given me the the positive part of it. So absolute value is going to give us the positive part of an integer. Let's try to note this thing down. We're going to use this later where and maybe possibly into the statistical operations where we want to need the negative values to get we simply want the positive out of it. Sometimes we have to find the mean squared error in a lot of operations. That's where we do this thing. Then we have comparisons. If I give, let's assume this will give this will return us the boolean values. If I try to give x is equals to 20 and y is equals to, let's assume 16. If I try to print is equal, it's saying me false. It's why? It is because x is definitely not equal to y over here. So in such cases, we can actually, you know, try to establish the connections between the integers, between the objects of those integers. This simply gives us whether those numbers are equal or not. In our over here, if I try to print now not equal, it should give us a true because the both values are definitely not equal. If I try to print the greater than, x is definitely should give us a return as false because x is less than y. So if I try to print the statement for less than, it should return us a true value since x is indeed lesser than y. You can see true is 1. If I try to see greater or equal to, it ultimately should give us false because it's definitely not that. You can see that false one. And finally, if I try to see if it is less than or equal to it or not, you can see that that's also true value. So if I try to change the value bit with 20 with 20, We can see it's equal. Yes, definitely true. Whether it's not equal, it's false because both of them are equal. If then there is greater than, yes, not at all. X is not at all greater than y or less than, there is also false value. And ultimately, final is here is it works as a more as a or condition. X is whether greater than y or x is equals to y. So if it is sufficiently finding itself, finding any satisfying any of the either condition, it will eventually give us a true condition. True result. In our case, x is indeed equal to y. That's why it's written as true. So you can see that's how we can do a lot of operations with on integers. So all these methods you have to learn. You have to do a lot of practice with it. Eventually, whenever we're gonna perform a lot of other operations onto it, in reality, in corporate world where we have to handle a lot of integer data. Ultimately, we're gonna need all of this method over there. Imagine you got an MS Power, Excel sheet, and you have to perform some sort of summation of other than differentiation or increment or decrement or some sort of finding some absolute values out of here or comparing the different values. We're going to read all of this, and finally we have this round and floor division. Yeah, everybody knows what does it round means. It will give us the if the value is greater than, let's assume, more than 5, it will give us the absolute value of 3, and if I try to put it over here as 6, it will give us a value of 4. So after decimals, we try to check whether it is greater than 5 or not. If it is greater than 5, it will give us the next possible integer value. It's basically rounding up that value. Okay. I hope I'm able to explain you correctly. It's not that tough because ultimately rounding up is basically is removing the decimals. Getting the real part of the integer. In our case, in this particular case, since we have 3.64, we have to ultimately find out which is, if I try to round up this figure, it would be eventually 4 since 6.64 is greater than 5. And in the same case, if I try to print the result flow division, it will also give us the, if I have to initialize this y as, let's assume 30, x assume 4. It has also given us the 7. So what does this floor division means? In our case, in this particular case, it tried to find what is the absolute value. 4 sevens are 28. That means 2 is remainder in this case, and 7 is that value that we got. So it will only give us the absolute value, basically a quotient value. In case of round floor division, we have to do it by double slash. It will give us this absolute value. So floor division also we're going to perform at a lot of times, and always remember you can use all of these operations at different type of occasions. So please try to revise them. Please do a practice bit of them. You actually get good at the integers. So next time we're gonna focus on to other data type that's a float, as another twin brother of the integers. So until then, keep practicing. Do like, subscribe, and share. This is Rahul Bird. We're gonna again meet later and keep practicing, guys. I mean, that's all from my side for today. Thank you. Yeah, bye.